Adam Savage in the cave with a one-day build with a friend today. This is Matt Parker of Stand Up Maths and Numberphile fame. If you don't know what those two channels are, well, you can follow some links in the comments below and have your mind regularly blown as I do. But we're doing a craft project today.
Yes.
Are we building regular solids? Is that what we're building? Oh, really? It's complicated?
With this, okay, so rhombus,
Yes.
all the sides are the same.
Parallelogram.
Yes, very nice.
Okay.
The angles, that angle's not the same as that angle.
No, but it's identical to that angle.
Exactly.
Okay.
So regular-ish.
Oh, a regular solid are polygons that should be all equivalent angles.
Yes.
So a tetrahedron is a regular solid because it's 3 equilateral triangles, all the angles are the same. So this is a slightly irregular solid. But the faces are all the same.
Exactly, the faces are identical.
Okay.
And for me, that counts for a lot.
What you don't know is that I used to work for a toy company called Zoob, which is a building toy based on ball and socket joints. And one of the weird specialties I got with Zoob is I made hundreds of Archimedean and Platonic solids out of the toy, and they all hung above my office.
This was your job.
Oh, well, I was R&D for this toy company, and the main thing I got obsessed with, once I learned that if you could do a 3 vertice and a 4 vertice, you can build all the solids. I just started building Platonic and Archimedean solids and the great stellated versions of them and the truncated great stellated versions of them and the pairings, and it's really, really fun.
That's amazing. Well, did you do, because
I never did this one.
Good.
And so what is this one called?
So we're going to make a rhombic dodecahedron.
So rhombic means the face is a rhomboid, but it's 12 faces, because dodeca means...
dodecahedron.
Okay.
So the classic dodecahedron is made out of pentagons. And they're the regular ones. So because it's the regular one, people don't bother specifying. We have to specify rhombic because it's still 12 faces, but they're not all regular shapes. So they're all identical.
Unless people start to go, oh, a soccer ball, in their head. A soccer ball is not a dodecahedron.
As you know, yes.
It is an icosahedron?
It's a truncated icosahedron. Very important. And so the Archimedean solids that you made, they're ones where all the vertices, all the corners will be the same. The Catalan solids, of which this is one.
Catalan?
Yeah, the Catalan, yeah. So,
or do they want freedom from the rest of Spain? Is that why they're called the Catalan?
Yeah, the Archimedeans won't let them even have a vote. It's insane. So in this case, the vertices will differ. Some of them have 3 meetings, some have 4.
Okay.
But the faces are all identical. I'm a big fan of the Catalan solids.
Excellent. This is a new regular-ish solid for me, so I'm excited. We each have, I think you have 14, or I have 14.
It should be.
It's 12 faces,
12,
right?
1, 2, 3, 4.
3,
12.
6, 9. I have 14, so I have 2 extras.
Okay.
We have some cello tape here, as you would say in the UK.
That's the one.
And I thought we'd just assemble these and start talking. This is the first of a 2-phase build, but this is the first one getting to know the solid.
Yes, and you can go slightly wrong if you just start sticking them together. I think the only, because you could just build like a prismy thing like this.
I'm assuming that this
fun.
is the beginning. Is that correct?
Yes, that's the beginning.
Okay.
And then you need to put, if you kept just doing 3s, you'd get like a cube that's been pushed over.
Oh.
Whereas if you put in a 4, that sends you on a different path, and you'll end up with a rhombic dodecahedron.
Oh, I'm psyched that there are ways to do this wrong.
It makes it more fun.
We will also, in the comments, include links to how to build this yourself, because it's a very easy shape. There's only 12 of the same thing. Let's
Do we
get
peel
started.
off the film
Yeah, we have to
before
peel
or
off.
after? Okay.
Now, all
Always
before.
before.
You're in luck that we've chosen the this plastic-covered acrylic, because when it's covered with the paper and it's old, it can sometimes be an absolute nightmare to peel off the paper.
Whereas this...
It's being very cooperative.
Does it bond over time, I guess?
What's fascinating when you actually start to build these out of popsicle sticks or anything is it starts to become surpassingly easy for your brain to parse the pairings of the polyhedra.
Yes.
How some are snuck inside others.
And this is why it's really good fun to build these things, because math can be quite, abstract, very theoretical, whereas actually building a thing and getting your hands on it, particularly putting it together, you're like, that's why the octahedron and the cube are the same.
Right.
Because they all are. And actually, the shape we're building can be thought of as an inside-out cube.
Oh, really? inside out.
Really hard to get your head around. Once we've got one of the models together,
Yeah.
I will show you. Well, you'll. Yeah.
Oh, let me get some X-Acto blades for us, just in
It's
case.
going to take me 1.5 times as long to do this. Exactly.
So I know that that's correct, right? I can assemble those two.
So what's the technique? You just kind of hinge it.
I'm thinking about that the tape sits on the outside.
Okay.
So I'm gonna go like that, and then I'm gonna use my X-Acto blade to cut up here.
And is there enough give in the tape that will...
That's what I think, is that there should be. Yeah, that's quite nice.
Because you're going to need to get to 120... This angle in here is 120 degrees.
Okay.
So it's like a third of a circle.
And I'll attach a piece to each of these.
It's kind of a spoiler alert, but one of the reasons why I love this shape is you can stack them and they perfectly fill space.
Oh, really?
And one of the reasons is because this angle is exactly a third of a full revolution. When you put 3 of them together and they all, no gaps. It's perfect.
And go across. And then I'll let it pull. Oh, this feels, it's...
Is it?
I think you might find the same with that tape, is that it's a nice substantive pull.
The right amount of pull that's going to give it a bit of strength once it's in.
All right, so that's the beginning. So, and does this have a, did you say it has a cube as its, so I'm assuming.
Sort of.
Let's see.
So yep, that's it. So you can see that's your 4, where there's 4 meeting, and that's your 3, where there's 3 meeting.
All right.
If you took this one out and just brought that one over, you'd be making a different shape.
Right. Right, that would be a, that would be a different shape.
Different shape, yeah. So you can imagine filling in the other...
it totally can work, the shape can work for that.
Yeah, there it is, yeah.
Oh,
so
like a swish cube.
There's your cube you pushed over. We're going to do better.
Super cool, all right.
Like several steps behind you.
Well,
it's not a competition.
My expertise has been weird builds of strange things.
That's very true.
All right.
Oh, yeah, I can feel. I think there's just enough give.
Yeah, just so. And then once you've gotten it, if it's pulled a little bit, you go back in and flatten it out.
It's a little grumpy, but it's going to do it.
So then, is that correct?
Yep.
Okay. I also like these builds because I like to imagine that it will be somebody's lesson to plan soon.
Yes.
Right?
Everything I do, in the back of my mind, I'm thinking, how will a math teacher be able to steal this idea and do a lesson with it?
That's great. And then we'll pull this. Oh, yeah. This type of slightly flexible clear tape. I like the clarity of this stuff. This has a little bit of a foggy aspect to it, but these things are really nice.
Okay, what am I going to do here? I've got that one there.
I'm assuming that goes there. And I've got 2, 4, 7. Ah, I see. So it's another one of these. And it shoots onto the top.
So have you got 6 there so far?
Yeah.
Yep.
All right. Then I'm going to start the same way.
I said it's a bit like a cube. You've got 12 faces we're putting together here. On a cube, you've got 12 edges. Oh. And so actually, each face, the arrangement roughly corresponds to the 12 edges of a cube.
Oh, wow.
And once you get it together and you pick it up, you'll start to see that in a way that you'd struggle to see if it was...
if someone was explaining it to you in the abstract.
Exactly. Yeah.
Ah, yes, now I see. All right.
It's nice. It's like a pleasing mini version of doing math where you get confused for a while and then suddenly it makes sense again.
Right. Well, it's hard to match the 2 shapes to each other. Before it was super organic, like this one to this, sure. And now it's, right, okay. So you live here. That's the way I describe it with the pieces. I want them to know where their home is. You live here. Don't you want to go home?
Maybe it's too good for its home. Feels a lot like a terrarium from the 70s or something.
Oh, very much. Yeah, totally. The chirality works no matter what, so I'm assuming.
It's not a chiral shape. Oh, it actually depends what sections you're building it in. You might chiral yourself into a corner.
Oh, right. They're not chiral specifically means can only go left to right one way.
Yeah, exactly.
Like they're
Or
reverses of each other.
If you reflect it, you get a subtly different shape.
Like this. Doink.
Yep.
And that's our shape.
That's your shape.
Oh.
Oh, that's very clean. Look at it. That's nice.
I like getting to know a new solid. I think when we do the second stage of this build, we might have to choose a different technique because I think we're going to have to leave one face open. Oh, or we assemble it, cut out a face to work on the inside. But now I'm doing spoiling.
Yeah.
So we gotta shut up so we can get to the next step.
I've taped them on the wrong way around, haven't I?
Always like this.
I've done it around the other way. Oh my goodness. The important thing is I gave it a go.
Can we come up with a Parker solid where 9 of the 10 faces are exactly right?
Yeah. Why is that one wrong?
Actually, is there a solid in which all the faces but one are the same?
Ooh, all but one.
That's a.
Yes, I mean, you would have like a pyramid shape where if you had like a hexagonal-based pyramid, you'd end up with that kind of a shape.
And there it is. That's all the faces, all 12.
I lost some ground, but back in the game, I'd like to think. That's better. And now they're just going to fold in. Okay. This is like an extreme version of in math. You'll want to doodle and sketch things.
Right.
So even the most advanced mathematicians working on all sorts of like weird theoretical geometry or anything will still be constantly drawing little sketches and stuff.
Really?
But building models just helps so much more to visualize it.
Yeah.
Actually, my wife's a physicist. So she looks at the structure of the magnetic field in the sun's atmosphere.
Okay.
And on her desk at work are these pipe cleaners.
Yeah.
And that's because when she wants to talk magnetic fields, the students should just grab a handful of pipe cleaners, and then they will
start to.
And then they all know what they're talking about and pointing at. And
there's nothing like a physical prop.
Exactly.
I mean, obviously, it's like there's this aspect of knowing that's physical. Right?
Yeah.
It has to be in your body in order for you to understand it in your head. And that's why, for me, building stuff like this and understanding the way in which it tracks to a cube is really fascinating.
Actually, have you seen the cube hidden in there?
Let's see.
It's well hidden.
Okay, so in this, the cube, the vertices of this, the faces match the edges of a cube.
Correct.
Ah, okay. Yeah, I can. The faces match the edges. So edge.
I'm just buying time.
Okay, let's see here. I see it now.
He's got it?
That's it. Right? So here's the cube.
Yeah, you got it.
Here's the cube. I'm going to draw it.
Draw it in.
Cube, that's the bottom face.
Actually, if you want to do it exactly, if you go that same line, but go corner to corner.
Oh, really? It's that one?
Yeah.
Ah, all right. So if I go.
But you've got it. You've
1, 2, 3, 4. So that's the bottom of the cube.
Yep.
That's upright, 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 and then the top is the same thing.
Yep.
1, 2, 3, 4. There is the cube. Hold on, I gotta erase this shit because it's making me crazy.
That's the spirit.
There we go. There is the cube.
Yep,
I got the cube inside there, which is actually, it's super visible.
And okay, so you can also describe this shape as a cube inside out. So if you imagine a cube, a solid cube,
yeah,
you can imagine the 6 faces are pyramids going into the middle of the cube.
Yes.
If you were to flip all of those pyramids, so instead of going into the cube,
would each of these meet in the center?
Yeah.
That would
so
meet.
if you flipped these, they would all perfectly go in and make a solid cube.
Is another version of this is kind of a stellated cube, because each of the faces is proud?
Yes.
Is that correct?
Yes. I'm only hesitant because stellated is an ill-defined operation in geometry. Yes, we've put pointy bits on all the faces.
Okay. Don't get technical on me.
It's a pointyified. I mean, I don't know the exact use of stellated. It's a mess. So,
Okay.
so basically, if you put a square-based pyramid on each of the faces of a cube, such that if you were to flip them around, they'd all meet perfectly in the middle, you get one of these.
And so there's another solid in here of all equal triangles. If I wanted to make these prouder or narrower,
Yeah,
I end up with a
you
bend
split
on
those,
each
yes.
of these faces, and it's another regular solid of 24 faces.
Yeah, because you'll split them. So you're absolutely right. If you stellate it such that this becomes like flush or flat, whatever you want to call that, then you get the rhombic dodecahedron with 12. But anything other than that, you're going to get another edge here, 24. I don't know what that would be called. It'll be some kind of 24 triangled. They wouldn't be equilateral triangles. They'd be isosceles triangles.
Ah,
It would have a name. It would have a name.
So this bit where I can see the cube sitting in there, that's where my brain, like I get an endorphin rush, right? Like that's really, really neat.
And I often describe math as finding and exploiting patterns. And it's hard to give a catch-all phrase. Actually, the best catch-all phrase for math is the kind of things mathematicians enjoy doing, but that's not a very useful definition.
It's sort of recursive.
But I know, but it works. And mathematicians, you tell it to them, they're like, yeah, you're right, actually. And so, but here, finding and exploiting patterns. So you're spotting and you're like, okay, and that the fizz in your brain when you're like, suddenly it snaps into focus.
And a lot of the Platonic and Archimedean solids are defined that the vertices are all equal to each other.
Yes.
But this has some 4 vertice points and some 3 vertice points.
So the Platonic solids, ignoring the fact they have regular faces,
Right.
put that aside.
Okay.
Their 2 big properties are all the vertices are identical and all the faces are identical.
Right.
And so if you relax either one of those, you get different families. So if all you care about are vertices, but you don't care about faces so much, you get the Archimedean, or Archidean, whatever people call them, solids. If you want to keep the faces all the same, but you don't care about the vertices, you get the Catalan solids.
Now, we're going to do one more exploration of this shape, and you suggested it, and I love it, which is infinity mirrors.
Yes.
And so I've bought some super fine, high density LED strips, and so I think we'll attach those to the inside of one of these. I have some laser cut parts for a bigger one, like about 1.5 times the size, and some two-way mirror film.
Right.
So we have to attach the two-way mirror film to all the faces, but the big problem with this, for my brain, is how do you efficiently route the LEDs around the inside of this? How many strips of LED will we need?
Yeah, because you don't want to run it and then have to double back and...
I'd rather not, and I'd rather not have a solder point. Well, I mean, I will have some solder points.
But you want to minimize the solder points.
Yes. So how do we? What is the most efficient way?
So sadly, you can't do it in one.
Yep. I figured as much.
You need 4. And the problem is, so you see these corners here, where there's 4 edges meeting at a vertex. You could imagine if you're running the LEDs, you'd come in here and then out there, other stuff happens, and then you come in there and out there.
Or you could do from here to here,
exactly.
here,
and then,
here, and back around.
Yeah. So you can do it in 2 passes, in and an out, and in and an out. Where there's 3,
there's no.
can't do it.
There's just no.
You can go in and out, but then later on, the next time you come in, it's a dead end. You've got to stop. Or you could start at one of these and go out, and then later on do an in and an out.
All right.
So this was kind of the birth of topology. Studying shapes in the more abstract form was looking at ways you can traverse paths where you've got different numbers.
So that's actually a field of study that yields interesting
There's a whole
questions
thing. It started the bridges of Kronensberg, where people were looking at if they could walk around all these bridges in one continuous path.
Oh, it's like a traveling salesman problem a little bit.
Yes.
Okay.
And then someone basically said, look, your first condition is how many odd-numbered vertices do you have?
Right.
If you've got more than 2, you can't do it. We've got 8.
Well, there you go.
But 8 means, with 8 starting and stopping points, in theory you could do it with 4. And I've checked, and you can. You can have 4 paths that each start and stop at an odd vertex, and it all works.
Okay, so that means, and I'm assuming there are 4 identical.
There can be, yes.
Okay, because that means that when we're putting in these LED strips, they'll each be of a specific length, and they'll do a specific
Yes.
trace.
And they're all going to be the same color?
They are. It's all going to be
So
warm
you
white.
can't tell which one's which once they're in. Okay.
No, you won't be able to.
One way you can do it is if you look at this, there's like a ring of 4 that go around here. Mm-hmm. And because we know there have to be 4 of them, and there are, if you count the edges, there's 24 edges, it must be 6 per path.
Okay.
And I've worked out the easiest way is to start on one of these.
Yeah. Here.
Oh, here we go. Oh, nice. So
Yeah.
So you start on one of these.
And let's assume that would be like the bottom.
There's like
Because
your starting.
I want one out for the electrical wiring. That's the goal.
Okay, I gotcha. Because one possible path is you start here, you do a total lap of one of these.
Yeah.
You come back to I don't know if there are limitations on how sharp an angle you can turn.
We can actually adjust that by making little wire jumpers between
Oh,
them.
so you have like a little.
Yeah, it's just a lot of
bit of give
soldering,
and a
and I
loop.
can bring Sean
Okay.
Charlesworth over, and we can all sit and do some soldering for a little while.
That would be very therapeutic. Because I could redo the paths to minimize angle changes. But if you're okay with that, if you do a full lap there, and then you just run out 2 like that, down to there, and then you stop. And so if you do that, for this one here, you do a lap, and then you do that cross.
Okay.
Here, you do another lap, and then you do that cross.
All right.
And now that's that side done. And then the same for this one here, you do a lap and that
Okay.
cross. This one, you do a lap and you do that cross.
Okay.
So your starting points are going to be there, there, and then for these ones, we'll put them like there and there.
And they don't cross over each other if you do that.
No, they don't.
That's awesome. Okay.
They do. Well, they do these when you've got to get both sides through the 4s.
Yes.
Then one goes across, the other one comes across the other way. You could change that by diverting them off, but that's what I was doing.
For those of you following along, if we had a much bigger budget, we'd have some beautiful CG animation explicating all this and showing the parity between, but we don't have the time or the budget to do such a thing.
We got a Sharpie.
We have
and some perspex.
Sharpie and some rhomboids. But you can follow along at home by cutting this out yourself. Shall we get started on the craft project of making the big infinity mirror version? Have you ever seen one of these done as an infinity mirror?
Nope.
Awesome. So this could be a first.
This is why I'm so excited. When you're like, what are we going to build? I'm like, I've never seen one of these.
Yep. That's fabulous. So we'll build one for here, and then once you take off, I'll send you a kit for putting one together
amazing.
yourself, so you
So
can make
flat
one
packs
yourself.
and-
Yep, exactly.
Perfect. Oh, hello.
Yep. Yeah, we're gonna actually
you take
just
a strip
map
off
it.
the edge of gaffer.
Yeah,
That's amazing.
1,
I love it.
2, 3, 4,
Yep. Down.
5,
Yeah.
6. And I think just like we're doing here,
Yep.
that one doesn't. That can be just the kink,
That can
not
be
a.
the king. So there's our start.
Yeah.
The next start is here. Right.
Is there no start that comes to here?
Well, that's what I'm just thinking. Because
But it doesn't, because the start has to go through it has to.
Because the moment all the starts and ends are these,
Right.
And every one of these is surrounded by. You can't get across unless you came out and across.
How about around here?
yeah,
Yeah, because
yeah.
we could put a little black in the corners here
Yeah.
to cover up little wire. That's easy. So now the question is, how do we route the next one?
So you just want to tear off more of that tape.
I do.
Okay, so my original plan was to start here for this one.
Okay. So I think it's, from here. Oh, right, I see. It crosses
Yep,
over
yep.
it. Okay.
So that does a full lap back to where you started.
2, 3.
I mean, I found other ways of doing it where you do more of a zigzag.
Yeah, no,
and
that's
then
fine.
This was the easiest to visualize and describe.
There we go. So there's
Yep.
that.
So can you see now? We've done both of these, and
Yep.
we've done everything there. We then just repeat that. We do both of these, and then everything there. This, but symmetric.
Okay. Ooh. Okay, so where do we start?
I really want to have a go at tearing off. Can I do? Is this good? Yeah.
So wait, so it's this one, right? Down to here. Is that correct? Like it goes 1, 2, 3,
Yeah, whatever you do, we'll then
4.
do the remaining ones with this.
5. Yes. Yep, I can see it.
Hang on a second. Okay.
Isn't that lovely?
Why have I never? Well, I've done it accidentally before. Why have I
Oh
never?
no, this is part of the
Deliberately
language of
done
gaffer
that.
tape.
Yeah.
All right, so then this one comes down here. So this will help us figure out how big jumpers come off the thing.
And then
so
the last one,
you're going
I'm going to
here,
lap this
dun,
one,
dun, and then down there.
Yeah.
Look at that.
What was nice is I knew in theory, just from running the numbers, because I was like, okay, it's got 12 faces.
Right.
Each face has 4 edges. So that's 24.
Yep.
Sorry, 48, but they're all counted twice because you double count using that method, so you half it to get 24. I was like, boom, okay, 24 edges. And then once I used the vertices to work out there must be at least 4, and then divided that by 4, and I knew, okay, so in theory it can be done with 4 or more, but only once I then messed around with it and found these patterns for 4.
This is exactly the kind of thing where you can talk about it in the abstract, but unless you have a really, really good brain for holding crap in your head, you have to do it like this in order to talk to other humans about it.
When I was working it out, I grabbed some photos online and put them in photo editing software, so I could then sketch. And then undo and then re-sketch until I
I might have some. Oh, Sean, we could use some of this stuff.
Yes.
For our jumpers.
Perfect. That's perfect.
Yeah.
Because it's the nicest, lowest profile stuff. So then the question is, where do we start with the power, and how do we jump everything as the shortest possible distance? So that's
Should we do a bit of tape for where they come in and out?
Yeah. So let me get one more color. So here's a flag. That's one.
That's it. Hang on. There. That's the end of this one.
Right. But it could easily be the beginning.
It could be the beginning.
So that's why I was going to...
As long as we're systematic. Okay, mark that.
Yeah, so I was going to do the end of each line.
Got it.
It should be the same
It's the same.
distribution,
It
right?
is. Absolutely right.
And then the other two are here and here.
Yeah.
Okay, so that's one, and then... So it's kind of a perimeter thing.
So they're kind of clumped. We could move them around a little, but that's probably...
So it sounds to me... So what we want to do is we want to wire these in series. Yes, not in parallel. I guess, no.
What has to be the same? The voltage?
Actually, parallel should be fine.
I think we can, like at the end, we can jump. It doesn't have to be, I don't think it has to be at the...
So what we could do is have, we could say this is where the power's coming in, right? We could just say that. And that this needs a jumper of n times 3, and each of these needs a jumper of n times 1.
What if, because one of them's irrelevant, because the end just ends.
Right.
Right?
Right.
So what if we got this end and put it over here? Like, so we'll start this one. No, hang on, which one's that on? Red. Well, no, what I'm thinking is, we should put it there. I'm trying to think, if we can get 3 together, then you can ignore this one over here, and you've just got a power there, and then jump to one, then jump to the other, and then you're out, right?
Okay. I'm taking your word for it because my brain has stopped gathering new information.
Okay. I tell you what, let's do it with tape. Okay, can we take these?
So if you could arrange them so that they all terminated at the same spot.
As close together as possible.
Right.
So let's just think
here,
it through.
use this to draw the jumpers. Let's use the orange tape to draw the jumpers.
Deal. Okay,
Go.
so here's what I'm thinking. We, for argument's sake, will start... Oh, no, wait, actually... I think... Yeah, no, we're going to need... So, okay, so we start on this one here. Start here.
Okay.
We do the red.
Yeah.
The red terminates there.
Okay.
We then have to get from there to the next one.
Which is a jumper of n
Jump
times
around.
2.
What I'll do is I'll lay that in slightly just so it's more obvious.
Right.
So we do that and we get there.
So that's jumper 1.
So that's red complete.
Great.
Okay, we're now on green.
Okay.
So then we power all the green and we end up
jump
here.
from here to here. No, that's back to...
Done red, so we got to jump to this one.
Right. Okay.
So we...
That starts, it goes that to there, or actually there.
Yep, done this way.
Yep.
Right.
That way it doesn't cross over with another wire.
Got it, okay.
But again, all of these jumpers are the same.
So we've done red and green.
Red and green, and now we're doing, this starts at pink.
Yellow.
Yellow, okay. So it goes yellow, 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 yellow.
Ends up...
Going to pink. So again.
ends up there, and then we're going... And do we want to go away from this wire on this side?
So,
Okay,
yep,
right.
so we go...
And then job done. And then pink just terminates where it terminates.
So
I can't remember. On these, can you supply power to the middle?
yes.
So that helps too.
Oh, don't mess with my head, man.
Wait. You can branch them.
I think so.
Oh, that changes everything.
No, we're sticking with this. We only have a couple of hours.
We have no more tape cutters.
Well, hang on.
It's 39.
I don't want to say this.
You want to go into the branching?
Well, is there a reason why? Okay, so let's say we've powered up green.
Yeah.
And we started the power over here, and we've powered all the green, and green now like crosses over yellow. Can you just run
I don't know.
parallel?
I'm not, maybe. Here's the thing with me.
I can try it real quick.
I'm a satisfier. Once I have a rough solution,
You're out.
So I'm done. Let's
I like
move
to do
towards-
an exhaustive search, come up with 3 solutions.
That is a maximize. This is a couple thing that my wife and I learned. Some
Really?
people are maximizers. There's only one sandwich that will be the right sandwich to have for lunch. Some people are satisfiers. Give me a ham sandwich, it's enough.
I'm a satisfier on a menu, but
Oh, I'm a satisfier in everything.
Because with a menu, you eat it and it's over, and you don't have to live with the consequences.
true.
right? Whereas this, every time I look at it, I'll be like,
I just realized some people staring at this would be like, you are not a satisfier when it comes to prop replication. No, you're right. I choose my battles.
See? Exactly.
It's true. We all have the spaces and the hills on which we'll die. Listen,
because that changes everything.
I know, but that requires an experimental phase, which we don't have time for this afternoon.
Okay, we have a jumper
Sean,
solution.
39 centimeter jumpers times 3 between 4 sets that are that long.
And if you've got some spare time.
Oh, that's it. We also don't have enough of this to experiment with.
fine.
There we go. All right, this is our mirror film, and we're going to have to attach some of this to all 12 of our faces.
I'm learning a whole new skill here.
Oh yeah, this is, and just to be clear, we're going to do this badly. This will not be a gorgeous job. It'll be a workaday job, and hopefully the lighting effect will still come through. But this is inexpensive two-way mirror because
What is
it
this normally used for?
window screen for your car.
Oh,
Yeah.
it's like tinting for a car.
That's exactly what this is, and we'll use the same techniques for attaching it, which is a process of, let me get some scissors.
Has it got a specific side, or it's just?
I don't think it does. I mean, obviously the Mylar's on one side, but it looks pretty much the same to me. Although the underside tends to feel a little, it's hard.
Yeah. Yeah, it looks identical.
There's someone yelling at the camera right now, yelling at your screen.
Someone's
There is
right.
a side, I do this every day, and we don't know, we're idiots.
We do this one day.
Okay, so I'm just gonna cut a slice off here.
Okay, so you just cut it a little big.
That's what I'm thinking. And then we'll trim it later. Okay. You put a little bit of the soap on here, and then you put this down.
So it's not adhesive, it's just soap.
No, it's literally surface tension. And then you do this to get the soapy water out, and if you did it correctly, just wondering if I bring it all the way close to the edge.
Oh, so you're cutting it just shy of the edge.
Yeah, because I'm going to be sticking the light strips here. I don't need perfect edge fidelity.
Good point.
And it might mean, I think this is fighting these little edge artifacts from the laser cutting, and I don't want to fight those. Yanking. And then from the other side, we end up with something that looks kind of not amazing.
Ta-da.
Really? Ta-da. Yeah, exactly. Ta-da. At least it is staying.
I mean,
Yeah, no, that'll get our effect for us.
yeah.
It's not perfect, but that'll do.
I feel like I can see through it and I can see me in it.
Oh, and then we can use black tape on the edges just to hide, hide our
any
crimes,
light.
as
Yeah,
it were.
no one will even know. You can see me through it, and you can see the camera. What if I cut them down to near enough?
And then I'll do
stick
the
them on?
attachment?
Yeah, how's that?
Sure. Sounds great. All right, sir. We have all of our mirrored pieces attached, so it's time to start assembling this guy.
Now,
I was thinking about assembling them in a couple, well, basically assembling everything but one panel.
so you'd leave
missing.
like the top one off or something. And then you can reach in.
Yeah.
Is there any advantage? It's going to be one long continuous chain, isn't it?
Yes.
Because if you did it in halves, you've got, where's the ring of, there. Because if you did like these ones and this half, so you got like these 4s.
Yeah.
You could do 1 4 and then those 2 side ones on it, and do the other 4 and the other 2 side ones.
But we have a single continuous.
And then like a clamshell.
Let's
gonna
do
backfire?
I think you're overthinking
Okay,
it. Let's
so
do
then
them.
get in and- yeah,
Because
okay,
then
okay.
basically we're starting at one end and going.
But we're putting this on the inside, right?
The lights go on the inside.
Yeah, it's going to be bigger than this too. So
Yeah, it's going to be 1.5 times the size.
Yeah,
Look at
we're
that.
fine. Yeah, no,
N
I'm
plus
being paranoid.
1.5.
So what if we both do one on the ground,
Okay, so that's
and
the.
then like these, and then one vertical, and then they'll slot together.
What's funny is that there's many.
over.
I always love the weird math of a right triangle.
Right.
Of a three-sided right, because you always see yourself in the corner.
Oh yeah,
A
yeah.
retroreflector.
Yeah. And we're not far off that. So a
ret's
retroreflector
all
would be a
90s.
cube. Yep.
These turn out to be purchasable on Amazon
Oh my goodness.
for about $40 for 10.
That's amazing.
A little retro prism. Isn't that gorgeous?
so cool.
I'm
You can
planning-
see your own
No, I
eye
know.
in there.
Your eye, no matter where you look at it.
And you can't not.
Yeah.
You can't see it closed, obviously.
I
That's
know.
so cool.
No, this is another one-day build that's happening later. I'm not going to tell you about it.
Come on. This is both satisfying and terrifying. Yes. What's the easiest way to do this? Should we tape up one
I
of
think
them?
I'm just going to do face by face.
Do you mean just to hold it?
Uh-huh.
Love
I
it.
think that's exactly what
I
I'd
think
like.
my skill set has come into its own.
Okay, there's one.
I'm so excited to see this.
I
one.
know, me too. I love that we've got a...
And little glimpses
Yep.
of it kind of working along the way. It's tantalizing.
Is that all the... Is every...
Have we missed any?
Yep. Yeah. Okay.
Okay.
So, here we go. I'm putting on my helmet. There. Ooh. I didn't know this would fit over my head.
That's amazing.
That's freaking awesome. I see 3 versions of myself.
And we can't see any.
That's like a Doctor Who villain.
That's so.
When fighting Mirrorhead.
Do you want me to cut tape and hand to you? What's the,
Yeah, if you
how do we
want to start
parallelize
tearing
this?
some pieces that are about that size, that's great.
I'll use this as like a measuring.
We call this hiding the crime.
It's really
Because
coming
it
together.
makes it look like you knew what you were doing.
Yeah, a multitude of inaccuracies are now hidden.
Oh, yeah. Oh, wait, I've got one more piece
Okay.
here that I've been hoarding, just in case you were taking too long.
Oh, good to know the level of confidence you've got in me.
Prepare for the worst, hope for the best. That's my goal.
Okay.
Dude,
That's incredible.
So there's your loose end.
okay.
That's the end.
This is your power end.
Power end.
Red is positive.
Okay, so if...
So how do you want to do this?
Where are we going to do? So we're going to have to follow this map.
Yeah.
We're going to have to start here on red, right? And then we'll end up back... Ooh, no. Oh, yeah, I guess it doesn't
Do we
matter.
end? Hang on. Did we end on yellow last time?
We
can't
might
remember.
have. So that goes, that jumps
Yeah.
right to here to pink.
Oh, no, wait.
And I think pink is the last one. No, pink then jumps to green, Goes
Green
dun, dun,
jumps
dun, dun.
to red.
Green jumps to red, which goes like this, and then red starts.
Red
Back to
starts.
green.
Oh, no, that's not a join. That's just. It's
Oh,
just
okay.
there. Yeah.
So, why don't we say?
So, if green's last.
No, that would be.
one's-
That's a jumper. I think this is. I think you're touching the origin on red.
Yep. And then where's the end?
Well, let's say that this is the end.
Okay.
And so that's where this comes out, and so we should start there. Flip
Right.
this whole thing over, right?
Because what we really want to do is do this top one.
Yep.
Is to be the last full lap.
Oh, is that what we want to do?
Well, I'm just thinking that might make it easiest at the very end.
Okay. Okay.
The last thing we do is we come up and up and then around.
Okay, then here's what we do. We grab a Sharpie and we number these.
Yeah. I love
Number
what
these
you
all
do.
the way
Okay,
around.
yeah. Okay, yep, love it.
That's our open. So we'll start. Yeah. We'll start here. So I flip this over. Is that correct, Sean?
Yeah, I would start with the loose end because
Yeah.
otherwise you're going to have all of this
Okay.
inside the
Yeah.
cube.
Okay, so
Or
then
not
if
cube,
this is,
sorry.
then I'm just going to start numbering. This goes like this: 1, 2, 3, 4, 5, 6, 7. Jump to red.
So green goes to red, yep.
8, 9, 10, 11, 12,
And down here.
13. Oh, that looks like a B. 13, 14, and then that jumps to green.
Where?
Oh,
No. We haven't got a jumper on that one yet. So this one
Yeah.
has to now go,
to here.
Yep, can go to there, yep. That gets it to pink.
15, 16, 17, 18, 19. This is 20, right, because it goes green back to here, pink back to here. 21 and connects directly.
It's got to jump to there.
21 jumps 22.
Yep, that goes to yellow.
22, 23, 24, 25, 26, 27, and 28.
Job done.
Okay, so if that means, oh, right. And that comes back out where did we start? We started with this being the open one.
So, as long as we don't reorientate this as we go,
Oh, okay.
we
guess
start
just
here
where
at 28 and work our way back.
Okay. Where is 28?
Don't know.
Thank you.
we can no longer trust these orange ones.
No, we can't. The orange ones don't make any difference.
So let's not move this again.
Right.
And not move that again.
Got it.
And
Okay,
so-
so then we start
You start there.
28, right there. Okay.
Yeah.
Here we go.
I'm going to mark them off as we do them.
From there
28 goes straight across to 27.
to 27. So here to here. Okay.
Could
Nope.
we temporarily number these on here?
Negative.
That's a no.
All right.
You're going that way.
Which way? I'm going laterally across, right? So here. Because this is the opening.
Yep.
Yep.
Then you're going to come up to this one over here.
All right. Which one?
You are.
Okay, so I'm coming through the bottom, right?
Let
And
me
where's
get-
26?
27 is now. You're going to here, 27.
And then
you go straight again.
to 26, right? And then where's 25?
Okay, 25 is then up here.
It goes up to the open.
Yep.
Okay, cool.
It's a one-person job in there.
I'm coming all the way around, yes?
The great thing about the mirroring is I can watch your face as you're doing it.
That's
Yep,
a jumper.
See,
So
that
it doesn't go all the way around.
So it should. Let's have a look.
Oh yeah, I guess it does, doesn't it?
What you're going to do now is, you know, you've just done a lap.
Okay.
You're
so,
going to jump to the opposite one with the jumper.
so is that here?
Have you just?
Oh
gone,
yeah.
Yeah.
If you're open,
Yep.
I'm coming
you've just
to here.
gone. You've just gone all the way around here.
Yep.
And then you're going to jump over to that one there. That can be of any use.
Oh no, I know. This is such a Such a weirdly specific problem to solve.
I mean, I'm very happy to have you solving it.
I know the inside's going to be a little ugly, but I don't care.
No one's going to see it.
Okay, so I'm coming up. This is the face I'm doing.
Yeah, so why don't you...
I'm going to put it down.
Ah, smart. Nice.
I've got yellow, right? That was yellow I just did?
Pink.
Pink. Okay,
I don't
so
know if
now...
you want to enjoy the fact you're halfway.
What's that? I'm halfway?
Halfway.
Excellent. Halfway
Now,
is good.
The next one's a little tricky. Could you put the opening at the top again? Mm-hmm. And can you see where you've terminated is like one down? Where is it?
It's one down, yes.
It's right there. So what you're going to do is patch it to this one.
Okay.
And then... Yep, that's it.
Great.
And then
Cool.
let me just double check we've got this right. Then this should run down, and then you do the full lap on the bottom.
Great!
Yeah.
Okay, cool.
Easy.
Awesome.
And then we're up the other side, and we're out.
Amazing. This is it.
That's it.
That was it. Okay, we have a little doubling up here. Yeah, screw it. Good enough. Good enough. Okay, now we tape on the last. Is that the inside or the outside? That's the inside. There we go. I don't think we need this.
Should we just black tape it on?
Before we do this, we don't seal anything until we've tested
You
the
a
circuit.
tester before you seal it kind of
Thank
person.
you. Okay, good enough. I didn't want to actually even take a look. I just wanted
Trivial
to make
amount
sure
of
it was
testing.
working. Where's the other black tape that you were
it's
holding?
over here.
That's the stuff. It's the matte. All right, so, haha, it's matte.
That's matte.
Okay. Dude, that is not
That
bad.
is
for
really
like
cool.
About 3 hours of work, and it's not pretty.
It looks way better than it has any right.
Okay, here we go. Let's we're gonna turn this off, connect it up. Will you tear me a couple pieces of that black tape?
Just to separate those.
Yep. And just that, perfect. That's one. And that's the second one. Because I want to be able to pick this up, obviously.
Yeah, exactly. You
Right?
don't want to...
Okay, here we go. Oh. We want to turn off the light, right? Hold on.
Oh
I'll be right
yeah,
back.
good point, good point.
All right, side lights off.
Off.
Camera still sees us, right? Here we go, the moment of truth. This is a rhombic dodecahedron with internal lighting on all of the internal edges and two-way mirror. Infinity box, here we come. 3, 2, 1, bop!
Oh, it works!
It's beautiful.
Oh, that's so good.
Wow.
So, one of the great things about a rhombic dodecahedron is it perfectly, if you repeat it, it fills space.
Oh, so wait, these would stack perfectly?
Yes, but if you look in there, you can see the phantom ones, which are in exactly the correct positions as if it was a lattice of these.
Oh my goodness. Okay, I need to build one of these things for real. We're missing two faces.
Are we missing two faces?
We're actually, we have a
we've lost
circuit
these.
problem. We have a circuit problem.
Which one's
We have
gone?
Some of them are out.
Yeah, and that one.
Yeah.
Which path is that? Imagine how amazing it'll be if it all works. The problem is technically if a few are out, if you look at the lattice, infinitely many of them aren't working. Which is
Really infinite.
Infinite.
I think infinity here is, I can see about,
Hypothetically.
this infinity I can see about 3 meters into it. I believe.
Okay. I hear you.
Wow.
So you could, in theory, do this with any shape.
Yep.
But you would get weird distortions because other shapes don't perfectly tile. They don't perfectly stack.
That's why you get such linear.
Whereas here, you get this perfect lattice and everything lines up. Wherever you look, it's just extending off perfectly in every direction. And not many shapes do that.
Okay, I'm totally going to build one of these for real and make it kind of nice. Because this two-way mirror thing isn't quite perfect here. I think I can buy the stuff that I want.
It just goes infinitely far down. It's got like
It looks like there should be a dark side to it
It's
as
just
you
a
walk
void.
around
Exactly,
it.
you walk around, you're
because
like, oh,
nothing
look at the
gets
back of
through
it.
it.
Yeah,
It's
it's
really
like a
kind of
proper-
amazing. Matt, that is a fabulous maths build.
But for realizing, like I knew hypothetically, because I sat there and I was like, I think this should work. Like in theory, this should look incredible. But you've made it, it's a real thing now. That's.
All right.
Oh, thank you so much.
I'm super excited. We'll make a pair. We'll send them to you, and then this deserves to be sitting on your desk.
It does. It adds a lot of space to a room.
Really? Thanks, sir.
My pleasure. Thank you.